Hello guys, welcome back to our tutorial. I think today what I'm gonna talk about is GIS data. Um, it's a special type of data, and you have to get used to it. So when we talk about GIS data, and the most important concept is what we call geodatabase, because GIS it's not like AutoCAD, like what I said before. It's not like AutoCAD or SketchUp. Jet you can just click in the Windows Explorer, right? So for example, what I give you the data is is this, right? We look at this like a grain bucket, like a bucket. Um, these are what we call geodatabase. Okay. You can see here we have 4 geodatabase here, um, which is just especially TATT raster and TATT vector. These two are really important ones. It keeps all the data, important data. Okay. And in terms of data format, most landscape architect will work with is 4 type of data. Um, like I kind of already got, for example, the first one, like like here with like this kind of like thumbnail. It's called shape file. You can see their extension code SHP. So that's what we call shape data. And when you open up, you can see here it's basically it was like it's just like what you draw lines AutoCAD, and you see here the lines. It's a vector data. What we mean vector data is when you zoom in and zoom out, it doesn't change anything. Okay, it doesn't get blurred. There's no change on this one. Okay, so this is one data type, and you also have your table associated with it. The other one is what we call image. Okay, when you drag in there, so this is what we call image. So basically, what image was, it's actually a picture. It's made by pixels. When you zoom in, for example, we zoom in to really fine level, you can see it get blurred because it's made by pixels. You know, when you zoom, you just one identical square. Okay, so that's what we call raster. And image file is raster. Okay, but will you notice that shape file, both shape file and image file are not in geodatabase. So basically what we image and shape file was is they are used to transform or copy data, or give data. You want to give data to somebody, or through email, or download from a website. This is the format you got. And it's actually not a working file type, I should say, because we cannot do much like calculations or GIS tools on it. It's just for download or transfer to other people, or other projects like that. Okay, and then let's look at our database. So the same thing here. So this one is what we call a raster. It's like image, right? It's made by pixels. When you zoom in, you see here, you're getting just a square by square, right? Pixel by pixel. But if let's just drag let's just find some infrastructure. Okay, let's just move like highways down there. And this is vectors, right? When you look at it here, when you zoom in, it doesn't get a blur, right? So this is what we call a vector. So for vector data, there is line, point, and polygons. This is polygons. Let me see. Zoom to layer and see here. This is polygon, which is a shape, right? And the point, skip some points. So these are points, right? Points, lines, polygons, and raster. So basically, these 4 types of data you are working with. And please remember, every type have a table associated with it. Okay, cool. So next, coordinate system and projections. One thing you need to notice that all these files line up perfectly. The reason they line up perfectly is because they all use the same coordinate system. When you look at the world, you know, our Earth is actually a sphere, right? But you want to present them on a map, like in a piece of paper. Then we need some rules to represent that. So that's why we need a coordinate system and projection rules. So in GIS, the way to figure out what kind of projections and coordinate system was by right click and go to properties, and in the source you can find out the projected coordinate system. In this case, it's NAD 1983, and you can know the unit, the linear unit of your map, which is feet, and also coordinate system is GCS. Okay, so that's, and the angular unit is degree. So that's kind of like the format of data that's stored in this layer. And because all our database are all formatted, and most of the database the data you got is formatted. So just you don't have an issue with like basically all the layers are using the same coordinate system, project system. If you have issues with the coordinate system, for example, if you have a data with different coordinate system, and when you drag it in or open up in GIS to then find them line up, just let me know. It's getting complicated issue by issue if you want to work with it. But I don't think we have any issue in this course. Okay. And also make sure the layers. So these are called layers or data frames. You can check the coordinate system by right click and click properties, and you can find out the layers using NAD 1983. North Carolina. You use like the same coordinate systems. So that's why they all line up. You just need to make sure you understand that. Okay, then let me introduce the database in our studio. So you get a folder, and there's like a lot of file. Actually, some file is just like it's not that important. You can delete them later, but there's some key parts. One is TAT T raster, and one is TAT T vector, and the other one is parcels. Okay, and all these parcels, for example, these parcels, if you drag anyone in, like pickles, it just have like every single property lines, also property lines in the county. Okay, and you can right click, and when you open the table, you can get all the information. Okay, who owns it and what's the name, the address, and zip code, sale price, even for some kind of property. So parcel is one, and the other is this two geodatabase TAT raster. And in TAT raster, you have it basically it's like all the information or surveys by Natural Resource Department of South Carolina and by USGS, those kind of agencies. This have two or three parts. First, in environmental. Here you have amphibians. Look at that. It just show the possibility. I think it's the occurrence or the possibility of amphibians of the land. And like a canopy, it definitely shows density of canopy, right? And croplands, and this is DEM, which tell you the elevation, okay? Forest groups, forest type, different type of forest. It's there's a lot of information in mammals, reptiles, some animals, right? This is slope. Show the different slope, which is important to me. Hill shape. Show where it's mountains, where it's flat land. So I think what you want to work with this is just try to understand each layer, okay? For some ones, for example, reptiles, it just have it don't have like a table, just have these values. So you don't need to know what are these single value mean. For example, this have value 25, but what does 25 mean? You don't necessarily to know that, but what you need to know is what are the lower value mean and the higher value mean. Okay, so in this case, I think the the lower of the value, the less reptile it will be. So you just compare with just use some common sense, okay? Like this DM is definitely the darker, the lower the elevation is, right? So just figure out all these layers, learn from it, and you will know what kind of data you have. The other important one is what we call land cover. So this one is important is because it basically helps you classify all important land use or land types. If you look at this, like cultivated land, deciduous forest, developed land, in different density, shrub, autumn water, mixed forest, woody wetlands, deciduous forest. They even help you differentiate different type of forest, which to me is really cool. So this definitely look into that. Make sure the value is here, right? Make sure this was the value. Okay, this was this, and let's look at the vector. For here, we have the same. We have a lot of data in here. Some are just points. This is census, which tell you or the population. Let's just drag one. You can tell. You cannot tell here, but you can just open up. They have tons of information. Okay. House units, whether or not how many vacant house there are, how many renter there are. What's the area of this region. So definitely look into that. Boundaries just tell you all the city boundaries, or the city boundary of Clemson or something like that. Different city, if you look at this one. And commercial areas, groceries, historical sites, different places. Okay, they identify that for you. Community cultural facilities, gardens, hospitals, churches, academic libraries, all that, right? education, schools, public schools, different types of schools. It's all in here. Hydrology. This one is a little bit complicated. I think the most important one is flow line. If you drag it in there, you can see here. There's a lot of flow lines, which they will show you like where water goes. Okay, where rain coming down, where is the water flow from different area. Pretty cool. So struggle. If let me change. If you so now you see here, that's like how water goes. Okay, and then also you can look at flood plains. See here, we'll know where we'll get flooded. Okay, and I bet there's a lot of information down there. Whether it's occasional or real frequent. Okay, so you will know where is the flooded area. Precipitation, definitely useful one. So you can understand different like weather, climate, also watershed. So when you open up flow lines, I guess sub watershed, or even high catchment. So you have different level of watershed, right? This is a big watershed, this is sub watershed, and a catchment. Okay, so basically you know, and when you open up flow line, you will figure it out. For example, in this area, for example, what this mean was, in this area, all the water will flow. All the water in this area will flow and flow in this direction, and then they will flow out from this point, right? In this point, they will flow out. Okay, so if I'm a piece of water from here, eventually I'm gonna go here. But if I'm a piece of water from here, I will eventually go out here too. That is through here, this way. But if I'm a piece of water, let's say here, I will go somewhere else. Okay, but so it's really important. It will tell you the mechanics of water flow and drainage. Okay, pretty cool. Okay, okay. So for our studio, for the database of our studio, it's really important. I strongly encourage you to look at them and learn from them, and please understand all the layers so we can communicate with you better. You can talk with your professor about the data better, and you can make a better design for sure. Okay. Then let's look at how to create your own database. Okay, because everyone, you don't want to work out with your data in here. Okay, in these two databases, what you want to do is create your own database and move the layers like this or specific layers, and move these layers you think it's important or relevant to your project, and drag and put into your database. Okay, so the way to create a database is really easy. What you can do, just right click, the folder, and click new, and then click file database. There are different types of database, personal database, but you need file geodatabase. Okay, personal geodatabase, choose more. So let's say file geodatabase, open up. Let's just say young database, then create it, right? So how to move? So if I think birds is what I'm trying to work on, I think it's important on my analysis. Okay, what we're gonna do is just right click, copy, and you just want to paste. The data transfer, click OK. Then it's in there. So the birds is still in TATT, so you didn't lost any data from the initial database, right? Or I think the same thing for vectors. Or high schools is important. I just copy and paste. Okay. You just need to copy and paste for between database, okay? Because birds is in database, I can copy and paste, right? But if it's parcels, if I copy, I want to paste to my geodatabase, you see here it's gray, which is you're not able to do that. So the way to work with like shape files and images, that is the file that are outside of the geodatabase. What we're going to do is right click your geodatabase and import. And if it was a feature class, vectors, like lines, points, polygons, and the raster dataset is images made with pixels. So in this case, I want to import, for example, I want to import parcels, so import a feature class. Just wait a minute. Okay, so you're gonna do is just go to further collections and find out the parcels you want to import. For example, I want to import pickens, add, and you make sure you name it, right? Output feature class. Okay. The one thing about naming is just remember one thing about naming is when you name, you don't want include space. A name cannot start with a number, so you cannot make this a name like a one young. That's not good. Or you cannot say it's young parcel. That's not good too, because you have a space. So what I'm gonna do is just say Anderson parcel. So this will work. Then let me click OK and just wait a minute. Then you will have then you just show up here. See here in my geodatabase, right? The same thing for the images outside of it. For example, this image, what I do just import raster datasets and choose what I'd like to include, alright? This one's here. Yeah, and click OK. Then there you go. So when we look at my database, I have all the data I need, right? So remember, don't work on the, don't work on this database. Just try to create your own database and collect your own important information. Okay? If you think all this information is important, because I don't think that's true. Okay? There are a lot of redundant information which you don't want to include in here, right? Somebody don't want to even look at soils, but somebody thinks it's really important. That's kind of so that's why you need to create your own. Alright, this for this, and also there are a lot of people in the past that asked me question about how I got all those kind of data if I want to do my own project or something in the future, because we kind of already have our own database already provide to you, right? So typically, when you work for a firm or you have your client will give you some GIS data because they own the land, they have information, and it's all stored in GIS. So typically usually you will have the data. But if you work on like your own project, like your thesis or something, I think there's a really good website here, which is clemsongis.org here. So this is a really good website. It have a page. You just in the menu, just select data, and you will find a lot of free JS data on the web. And you see here, there's global, continental, US, in South Carolina, and there are a lot of kind of data. You see here, statewide DEM, which is elevation, railroads, parks, hydrology, wetlands, reservation, wildlife, refugees. This is how I got those data. Okay, we got those data, where they're from. Okay, and the Greenwell JS department website, you have bikeways, buildings, city limits, floodways, future land use, bus routes, more specific, okay, in Greenwell. So different companies have different level of details, things like that, but you can find that. I think in the future, since when the studio goes on, you will need more data, except for what we provided. So please, if you want to do more data, please do it, and create your own data. It always helps. It's valuable information. Okay. And also the other way to get data is just through easy Google search. For example, I just search Charlotte GIS, and there's a lot of links, and usually the data is from county. So let's say this geographic information, Charlotte County. When I click, you will get a web page, and they will have a link that help you get, for example, download the GIS data, right? So you can download a lot of data from here. They will, a lot of data is public available. Okay, pretty cool. So in the future, if you have any questions, just let me know. Okay, I bet a lot of you, in terms of data, you have some of your own questions, but we can work with an individual. Okay, so I think this was for today. I will see you next time. Thanks.